Section 11.5, Volumes of Pyramids and Cones. Theorem 11.8. The volume of a pyramid is 1/3 the product of the area of the base and the height of the pyramid. Our formula V equals 1/3 B, where B is the area of the base. In this diagram, it would be a rectangular or square base, therefore it would be length times width. And H is the height of the pyramid. Recall the height of the pyramid is a segment from the vertex that is perpendicular to the base, while the slant height of the pyramid is a segment from a vertex that is intersecting the base edge of the pyramid. And therefore, we have this stated: B is the area of the base, and H is the height of the pyramid, not the slant height. Theorem 11.9, volume of a cone is 1/3 the product of the area of the base and the height of the cone. Similar to our previous example, V equals 1/3 B, where B is the area of the base. Here, our base is a circle, and therefore, the area of a circle equals pi r squared. Therefore, when I rewrite the formula, V equals 1/3 the area of the base, but our base is pi r squared times H. And this is represented in our diagram. Here's our height of our cone. That is a segment from the vertex that is perpendicular to the center of the circle, or the base. And here we have the slant height, which is a segment from the vertex to a point on the base edge. In this example, they want us to find the volume of each square pyramid and round your answer to the nearest tenth. We're given a square base, and I need to find the height because I know I can find the area of the base and substitute in for B, but I need the altitude and height of my pyramid, and that is a segment from the vertex that is perpendicular to the base. I'm given the slant height. So what I need to do is to generate a right triangle, and therefore I know that that would bisect the base edge, so I know that this would be 4 feet. And now I have a right triangle. I know one leg, I can determine the other, given the leg and the hypotenuse. Therefore, when I substitute in the Pythagorean theorem, r squared plus b squared equals c squared, I'm given 4 squared plus b squared equals 12 squared. Therefore, b squared, when I simplify, is going to be 128. And then that will simplify into the square root of, when I take the square root of both sides, 64 times 2, the square root of 64 is 8 square roots of 2. Now I substitute into my volume formula, V equals 1/3 the base, which I know is 8 by 8. Therefore, when I substitute length times width times height, I then use the calculator and get 241.36, rounding to the nearest tenth, 241.4 feet cubed. Again, I'm finding volume, and that would be in cubic units. The next example, I'm given an equilateral base. Therefore, I know that all segments of the base are congruent. I need to determine the value of the area of that equilateral base. I need to know the height of that base triangle. To do that, I'm going to put an altitude from a vertex of the base that will intersect the midpoint of the opposite side, creating a perpendicular segment. Therefore, I know when that bisects, that will give me 5 centimeters. Now, I know that this is an equilateral triangle, and I know that this has to be 60 degrees. And a 60, 90, therefore, by the triangle sum theorem, I know that that is 30 degrees. That gives me a 30, 60, 90. I know the short leg is 5 centimeters, and I know the long leg is the short leg times the square root of 3. And that long leg, which is this segment, is going to be the height of my triangle. Therefore, when I substitute into the area of a triangle formula, that's going to give me the area of the base. So the formula is 1/2 the base of the triangle, which I know is 10, times the height of my base triangle, which I know is 5 squared is 3. Substituting, I get 43.3 centimeters squared. Remember, I'm finding the area of a base. Now I substitute into my volume formula, and when I do that, I have 1/3 The area of the base I calculated is 43.3 centimeters squared times the height, which is the altitude of the entire pyramid, which I know is 12 centimeters. Putting that into a calculator and rounding, I get 173.2 centimeters cubed. On the next example, we're going to find the volume of a cone. We know that the volume is 1/3 base times height, but here our base is a circle, therefore it's going to be pi r squared. I know my radius is 4 meters. I need to determine the height of my cone. That's the segment from the vertex that is perpendicular to the base. That generates a right triangle with my slant height. Now, if I use the Pythagorean theorem, I can determine the altitude of my cone. Therefore, substituting in, a squared is going to be 4 squared plus b squared, which is going to be the height of my cone, equals the hypotenuse squared, which is 20 squared. When I simplify, I'm going to get b squared equals 384. Using a calculator, b is 19.6. Therefore, b is equal to the height of my cone. With that information, all I need to do is substitute into my volume formula. And when I do, I'm going to have v equals 1/3 pi r squared, that's 4 squared, times the height of my cone, which I determined to be 19.6. Plugging into a calculator, I get 328.4 meters cubed. On my next example, I have an oblique cone. Therefore, I have a radius, which I know is 6 inches, and my altitude is on the exterior of my cone. That altitude is the height of my cone. All the information given, I can just plug right into my formula. Therefore, when I do, I'm going to get v equals 1/3 times the base, but I know the base is a circle. That's pi r squared. That's pi, 6 squared for the radius, and 9 for the height. When I substitute into a calculator, I'm going to get 339.3 inches cubed. On this example, I have a square pyramid with a height of 80 feet, and it is the entrance of an amusement park. Each base edge is 100 feet. A pathway for the people to enter is cut through the pyramid. The pathway is a rectangular prism, 50 feet wide, 100 feet long, which is the length of all the base edges, and 20 feet high. Determine the volume of the structure. I've generated a diagram. I know from the given information that each edge is 100 feet. The height is 80 feet. And I know that the entranceway is 50 feet wide. And it is going to be 100 feet long. It's the same as the pyramid itself. And it's going to be 20 feet high. So what I have is the volume of a pyramid, and I want to deduct the volume of my prism. Therefore, what I have written is the volume of the entire figure is the volume of the pyramid minus the volume of the pyramid, because that's cut through for the people to walk through. When I substitute in, I'm going to have the volume of a pyramid is 1/3 the base times the height. Here, the area of the base is 100 times 100, and the height I know is 80 feet. The volume of my prism is going to be base times height. My base area of my tunnel area is going to be 50 feet by 100 feet. That's the base area. The height of my prism is 20 feet. When I plug these into the calculator, I'm going to get these two values, which is 266,666.7 minus 100,000. When I simplify that, I get the volume of my pyramid minus the prism, which is going to be 166,666.7 feet cubed. On my last example, I want to determine the volume of the fluid it would take to fill this conical tank. In other words, a cone. I have fluid in the bottom of my cone. The fluid in the bottom of my cone has an altitude of 7 meters and a radius of 4 meters. the altitude of the entire cone is 7 plus 13 meters. I still have an altitude space of 13 meters to fill up. So the entire altitude is going to be 20 meters. And the radius at the fill point of my cone is 6.6 meters. So what I need to do is find the volume of the entire cone, subtract out the volume of the fluid that's in there, and then that would leave the remaining volume that could have the capacity be filled. So what I have is the volume I wanted, which is the top part of my cone, and I want to take the volume of the total object, that's the total cone, and then I want to subtract out the amount that has been filled. Now I just substitute the values into the formulas, and then I simplify. So for the cone, I have 1/3 pi 6.6 squared. This is the entire cone, and that's the height of 20 meters. Then I subtract out the amount that I have filled. That is 1/3 pi, and here the radius is 4 meters, and that height is at 7 meters. When I calculate out, I'm going to get, for the entire cone, 912.3 meters cubed minus the part that's already filled, 117.3 meters cubed, and when I subtract, I'm going to get 795 meters cubed. That is still space that I can put fluid in.